Welcome to a special deep dive, crafted just for you, looking into the really, truly transformative role AI is playing in space exploration, like right now.
Yeah, it's definitely moved beyond just sci-fi concepts. The material we looked at, it really shows concrete ways NASA, ESA, space agencies are using AI. It's having a big impact.
Exactly. And we've gone through some fascinating sources, and our mission today, really, is to pull out the most compelling bits. How AI is letting us push the boundaries further, understand things better, and just operate more efficiently out there.
We're talking autonomous spacecraft, AI sorting through massive cosmic data sets.
Yeah, all that good stuff.
And we'll see how AI isn't just basic automation anymore. It's becoming this core intelligence, tackling problems that used to seem, well, almost impossible. You might see some surprising connections today.
Okay, let's jump right in then. This idea of intelligent autonomy keeps coming up. It's clearly way more than just, like, running a preset program these days, isn't it?
Oh, absolutely. AI is really giving spacecraft and rovers genuine independence. They make decisions in real time. And what's really compelling is, well, you need this for deep space.
Because of the time lag.
Precisely. The huge distances mean communication delays. Minutes, even hours. So constant human control from Earth is just not practical.
Right, you can't joystick a rover from millions of miles away if it takes 20 minutes for the signal to get there. So how does this autonomy actually, work in practice? Any examples?
Yeah, a great one is NASA's Perseverance rover on Mars right now. It uses systems like enhanced autonav and terrain relative navigation,
Okay.
which means it can perceive its surroundings, look at the terrain, and then decide where to move next, all without someone on Earth telling it, turn left now, go forward 3 feet.
So it's actually navigating Mars on its own, figuring out how to avoid rocks and choosing its path.
Exactly. And it gets even smarter. These AI systems, they can fuse different kinds of data.
Fuse data? Like what?
Well, radiometric data, that's from radio signals and optical data, from its cameras. It combines them.
And that helps how?
It results in navigation accuracy that's almost 10 times better than if it just used one or the other. Think of it like having both a radio beacon map and a visual map and merging them perfectly. Much more precise location awareness.
Wow. Okay, 10 times better.
Yeah.
That's huge, just by combining data smartly. So it sounds like they can even change course mid-mission.
Absolutely. That's another key part. AI-driven autonomous trajectory calculation.
Right.
It lets spacecraft adjust their paths based on, say, new mission goals that pop up, or maybe something unexpected happens. It makes them way more flexible than just sticking to a rigid flight plan set years in advance.
Huh. So if it spots something scientifically interesting or maybe needs to save fuel, it can actually figure out a new route on the fly.
Precisely. It's all about maximizing the mission's value in real time. And, this autonomy isn't just for deep space probes. It's also crucial closer to home.
How so? Oh, you mean like for satellites?
Yeah, exactly. Think about all the space debris up there. It's a growing problem.
Right. Kepler syndrome and all that.
Well, SpaceX's Starlink constellation, for instance, uses an AI autopilot. It helps the satellites autonomously dodge potential collisions with debris.
So it's like AI air traffic control, but for satellites dodging space junk.
Kinda, yeah. It's vital for keeping those orbits clear and safe, especially as they get more crowded.
Okay, so AI is the navigator, the pilot, the traffic controller. But what about the sheer amount of information coming back? The data must be just overwhelming.
Oh, you hit on a really critical point there. Telescopes, planetary probes. They generate absolutely mind-boggling amounts of data. Terabytes, petabytes.
Yeah, I can't even imagine.
Honestly, without AI trying to analyze all that, it could take scientists decades, maybe even centuries. It's just too much.
So AI is like our super fast cosmic data interpreter.
In a very real, very sophisticated sense, yes. Take finding exoplanets, for example. AI algorithms sift through the light curves, tiny changes in a star's brightness from missions like Kepler, TESS, even the James Webb Space Telescope. They're looking for those minuscule dips that signal a planet passing in front.
That sounds like finding a needle in a truly colossal haystack.
It really is. Humans just can't process that volume efficiently. AI finds patterns we'd likely miss or that would take forever to spot. And it's not just planets. AI also classifies galaxies, nebulae, other objects in telescope images.
Helping us map the universe's structure.
Exactly. Categorizing the cosmic zoo, so to speak. And it's also great at finding transient events, things that happen quickly and are gone.
Like what?
Supernovae, the explosions of stars, or even detecting the faint signals of gravitational waves hidden deep within noisy data. Imagine trying to hear a tiny blip during a thunderstorm. AI can do that.
That really drives home the scale. What about on planets themselves, like Mars? Is AI helping the rovers analyze what they see?
Absolutely. Rovers like Perseverance use AI with instruments like PIXL and SBOC.
Right, the ones that look at rocks.
Yeah, they analyze the mineral composition, the geology right there on the surface.
Hmm.
The AI algorithms process that data immediately, identifying what's interesting. So the rover isn't just sending raw data back.
It's sending back actual insights.
Yeah.
It's doing some science on the spot.
Exactly. A degree of on-the-ground analysis thanks to AI. And this even ties into SETI, the search for extraterrestrial intelligence.
How does AI help there?
Well, SETI involves scanning huge amounts of radio signals from space. AI is being used to sift through all that noise, looking for patterns that just might, be artificial, not natural.
Wow. So AI could actually be the thing that finds evidence of life beyond Earth. That's quite a thought.
It's a profound possibility, yeah. Overall, this rapid analysis capability, it's fundamentally changing the game.
Accelerating the pace of discovery, basically.
Dramatically. The sources really emphasize this. We're finding things and understanding things much, much faster because AI can handle the data deluge.
Okay, so AI is boosting our brains, helping us navigate, helping us analyze. What about the physical side? Robots doing stuff out there.
Definitely. AI is making space robots way more capable, not just the rovers we talked about, but also things like robotic arms.
So they're not just dumb arms following commands, they're smarter.
Much smarter. Rovers like Curiosity and Perseverance, they use AI for avoiding obstacles, sure, but also for deciding what science to do next.
Wait, deciding the science. How?
There's a system called AEGIS, Autonomous Exploration, for gathering increased science. It lets the rover analyze its surroundings and say, hey, that rock over there looks scientifically interesting. Based on my criteria, I should go check it out.
Whoa, so the rover has its own scientific curiosity almost. It can prioritize targets without waiting for Earth.
You could kind of think of it that way, yeah. And then you have robotic arms, like the Canadarm2 on the ISS. AI helps them perform really complex tasks.
Like what?
Satellite servicing, station maintenance, handling cargo.
Yeah.
Stuff that's tricky and demanding. It takes some workload off the astronauts and reduces risks.
So robot mechanics and assistants in orbit getting more capable all the time.
And maybe even companions. There's research into AI for direct astronaut support. Remember CIMON on the ISS?
Oh yeah, the little floating head thing.
Exactly. It was an early experiment exploring how AI could maybe offer information, companionship, support on those really long, isolated missions. An AI buddy, sort of.
That's fascinating, especially thinking about trips to Mars. The isolation is a huge factor, and AI helps prepare us down here too, right?
Yes, absolutely. AI is being used in VR and AR training simulations for astronauts, creating really realistic scenarios, spacewalks, docking maneuvers, emergency drills. Astronauts can practice and hone skills safely before they ever leave Earth.
So AI is really involved end to end, from training on Earth to exploring Mars. Okay, let's switch gears a bit. Communication. Huge distances, big problem. How's AI helping there?
Yeah, communicating across space is tough. You've got the delays, obviously, but also limited bandwidth, interference. AI tackles this in a few ways.
It's not just about bigger antennas then.
Not entirely. First off, as we said, making spacecraft more autonomous just reduces the need for constant back and forth. That helps right away.
Less chatting needed. Got it.
Then there's intelligent signal processing. AI can actually clean up noisy signals, filter out interference, making it easier to pull out the valuable data even if the signal is weak.
Like some kind of super noise canceling headphone for space signals.
Yeah, a very sophisticated version of that. Plus, AI improves error detection and correction, making sure the data that arrives is accurate, not corrupted.
Okay.
And it helps manage the networks themselves. AI can do dynamic bandwidth allocation, prioritizing important data when bandwidth is tight, making the most of what we have.
So AI is like the smart traffic cop for our space data highways.
That's a good way to put it. There's also something called cognitive radio. AI helps the radio intelligently find and use the best, clearest frequencies available, avoiding interference.
Huh? Clever.
And looking forward, technologies like NASA's Deep Space Optical Communications or DSOC using lasers, while not purely AI, it's the kind of system AI could really optimize further, pushing data rates way up.
So AI is making space communications smarter, faster, more reliable. Okay, what about the humans on these missions? Astronaut health is critical, especially for long trips.
Absolutely vital. And AI is becoming a really important tool here. We're seeing things like wearable tech, astroskin, other
Sorry,
biosensors.
tracking vital signs constantly.
Exactly, collecting real-time data on heart rate, respiration, temperature, all sorts of things. Then AI models analyze this data stream,
Looking for.
anomalies, early warning signs. They can help predict health risks, like SANUS, that's spaceflight-associated neuroocular syndrome, an issue with vision and the optic nerve, or other potential problems. It allows for early intervention.
So it's proactive health monitoring, not just reacting when someone feels sick.
Precisely, catching things before they become serious, which is crucial when you're months away from the nearest hospital. They're even developing virtual medical avatars, digital twins.
Digital twins, like a virtual copy of the astronaut.
Sort of, yeah. A way to visualize all their health data, track changes over time, maybe simulate treatments. It helps doctors on the ground understand what's happening.
Wow.
And even large language models are being looked at. Imagine an astronaut being able to ask an AI detailed medical questions and get immediate access to a huge database of knowledge, like an onboard medical expert system.
So AI is really shifting astronaut healthcare towards prevention and prediction.
Exactly. It's seen as essential for enabling those future deep space missions, Mars and beyond, where you have to be self-sufficient medically.
It's like giving them an AI doctor on board. Now, for those really long missions, living off the land, so to speak, becomes important. Using local resources.
Yes, in situ resource utilization, ISRU. It's key for long-term presence. You can't keep shipping everything from Earth. It's just too expensive and complex. AI is crucial for making ISRU work.
How so? What can AI do?
Well, think about finding resources like water ice on the moon or Mars. AI-powered robots could autonomously prospect, locate deposits, then extract and process them.
So robot miners and chemists driven by AI.
Essentially, yes. And AI helps them adapt. The environments on the moon and Mars are harsh, changeable. AI algorithms can help the robots adjust their strategies based on what they encounter.
They learn as they go.
To an extent, yes. A good example, though maybe simpler, is the MOXI experiment on Perseverance.
Wait, we're making oxygen.
Exactly. It successfully made oxygen from the Martian atmosphere. AI plays a role in automating and optimizing processes like that. Imagine scaling that up, autonomous AI-driven systems producing water, fuel, building materials.
From local resources. That really changes the game for building bases or settlements.
It makes it actually feasible, reducing that huge dependence on Earth. It could unlock long-term exploration and even things like asteroid mining.
Okay, this is all incredibly powerful stuff. But with more autonomy, especially AI making decisions far from Earth, there must be ethical questions, right?
Oh, definitely. That's a really important dimension. As AI gets more autonomous in space, we absolutely have to grapple with the ethics and the legal side.
Like what kind of questions?
Well, who's responsible if an autonomous spacecraft makes a mistake, a navigation error, a science decision that goes wrong? Is it the programmers, the agency, the AI itself? It gets murky.
Yeah, I can see that. Accountability.
And how do you ensure these complex systems are truly safe and reliable, especially in the extreme unpredictable environment of space? Radiation, temperature swings, and then there's cybersecurity, protecting these smart systems from hacking or interference, data privacy too.
So we need rules of the road.
Exactly. There's a growing need for clear ethical guidelines, maybe even international regulations. NASA actually has its own AI ethics framework already, which is a good start. But it's an ongoing discussion. Space poses unique challenges for designing and testing trustworthy AI.
Makes sense. You can't just test it in a lab quite the same way.
Huh?
Okay, looking ahead then, what's the really big picture? Where is AI taking space exploration in the future?
The sources suggest the future is, well, fundamentally intelligent. Autonomous AI is set to completely transform things. Think much more ambitious missions.
Like going even further out.
Further out, yeah. Maybe fully autonomous probes heading to the outer planets, even interstellar space eventually, making decisions and doing science for years with minimal input. AI could manage huge satellite constellations, complex orbital operations.
Wow.
It has the potential to massively speed up the search for life, analyzing biosignatures in ways we can't yet. It'll optimize everything, mission planning, using resources, predictive maintenance to keep things working.
So safer, cheaper, more efficient, more ambitious missions.
Pretty much, yeah. And it's likely going to be a huge driver for the space economy, too.
How so?
Things like asteroid mining, space manufacturing, making those commercially viable might really depend on sophisticated AI automation. Some people even talk about AI being essential for, actually colonizing other planets someday, managing habitats, life support.
So AI isn't just a tool anymore, it's becoming like a partner.
That's exactly the word many sources use, an indispensable partner. The future of exploring the cosmos looks like a collaboration, a symbiosis between humans and artificial intelligence, each bringing unique strengths to the table.
Well, we've really only scratched the surface here, I feel like.
Yeah.
But it's incredible to think about spacecraft that think, telescopes that discover in real time.
Mm-hmm.
It really makes you consider the possibility of humans living and working out there on other worlds, with AI being a fundamental part of making that happen.
Yeah, this deep dive really highlights just how woven into the fabric of space exploration AI is becoming. And it raises so many big questions about what that human-machine partnership looks like when we leave Earth behind.
The potential is just staggering, isn't it? And it's moving so fast, you wonder what we'll be talking about in just 5 or 10 years.
Absolutely. It's one of the most dynamic frontiers there is right now, that intersection of AI and space.
We'll keep exploring, keep asking those questions, and yeah, definitely keep looking up. Thanks for joining us on this deep dive into AI's journey into space.